ZEISS Axial Imager M2 is a fully motorized microscope which can control the motorized part either with the touchscreen over here or by the ZEISS software. The microscope is equipped with two cameras. The first one is the color camera overhead, and on the side is a monochrome camera. To use the light path to observe your sample either with eyepiece or the color camera, push this knob all the way in. To switch to the monochrome camera, take this knob all the way out. To control the movement of the nose piece, you can control it with the TFT or the touchscreen on the right side of the microscope. Press the desired objective length and then the nose piece will move. To apply your sample onto the stage, press the lower button to lower your stage. Then you can apply your slide onto the scanning stage. This scanning stage can hold 2 slides at a time. Once you're ready, press the upper button to raise your scanning stage to the upper position. For reflected light on the wide field microscope, use this rubber cover light to cover the light path underneath to block any reflection from the glasses. On the other hand, if you're going to use the transmitted light or bright field, don't forget to remove this cover to allow the light to go past to your sample. To control the scanning stage, use your joystick to move your sample or either move it via the software. Let's see. This is your wide field microscope equipped with the upright microscope. ZEISS Axial Imager M2. To turn on the system, press number 1, which is the UPS behind the computer monitor. For number 2 is the SMT 2009, which controls the scanning stage. Number 3 is the power supply of the microscope. Number 4, turn on the microscope over here. And then number 5 is the PC. To start using the microscope, double-click ZEISS software on the desktop. Now your ZEISS software is now starting. It will show you 2 panels. The ZEISS on the left-hand side will give you the full ZEISS functionality and allow you to acquire an image. On the right-hand side for ZEISS image processing, will give you the opportunity to work with the image processing and analysis. For this image processing panel, it won't connect to your microscope. Now, we're going to use our microscope. Click ZEISS on the left-hand side. Now ZEISS is starting. It is restricted to the user with the password logged in to your account. Right now, the ZEISS is initializing all the hardware connected to the software. It will take some time. First time starting with the PC, it will ask you to do the stage calibration. I recommend you to calibrate the stage every time it asks. Click Calibrate Now. Now the stage will move up and down in the X, Y, Z axis automatically. Please do not touch or move anything during this process. It won't take long. Once finished, you can now start working with the microscope. To start your imaging, turn on your ZEISS software. This is your ZEISS software interface. The workspace can zoom in and zoom out according to your desire. The workflow of the imaging are divided into many tabs. The first tab is to locate. To locate your sample, we already created the shortkeys just for easy usage of the microscope. For bright field, click BF. Once you click BF, direct your light to the color camera over here. Then click Live to start streaming your image on the screen. For 5x magnification, don't forget to swing out your condenser. To move to the desired objective lens, you can either change it from here with the TFT software or on the right hand side of the screen over here. To adjust the brightness of your image, you can adjust the exposure time over here. By increasing the exposure time, you get the brighter image. Or you can click auto exposure just to let the software determine how much light you need. Once you're done, click Close All. To close all the shutters you needed. For fluorescent microscopy or wide field, you can either click DAPI, FITSI, Sci3, Texas Red, or Sci5 over here. Before doing that, don't forget to add the light cover to block any reflected light. Click FITSI. To direct the light to your right light path, click the camera on the left-hand side of the microscope or the light path over here, and then click Live. Again, to adjust the exposure time, you can add more number or click Auto Exposure just to let the software determine how bright your sample will be. To start working with your reflected light or wide field microscope, you can easily just click DAPI and you will see the light shining from the objective lens. FITSI, Sci3, Texas Red, Sci5. To use the wide field microscope, don't forget to use the light cover just to cover any reflected light to interfere your sample. By clicking the light, then you click Live, you will see your live image on the screen. For the reflected light, don't forget to direct your light to the camera on your left-hand side of the microscope, the Cam 807. To adjust the focus of your sample, you can do it manually by adjusting the coarse on the fine adjustment on your microscope or use the software to focus your sample. In order to do that, place your cursor on your live screen and then press Ctrl on the keyboard. Then you can scroll your mouse. You can adjust the speed of the focus mouse wheel by clicking slower. This is your done. To move your stage and direct your sample into the direct orientation, you can just easily double click the desired position, then that position will move to the center. Screen, you can either move it by clicking the blue border on the four sides of your samples. The lighter shade blue will move to that direction by half of the size of the visible area. On the other hand, if you're clicking the darker shade blue on any side of your sample, it will move the stage to that direction for one full field of view. Once you're done, click Stop. And then, to close all the shutters, click Close All. Now you finish locating your sample, you can now move on to the Acquisition tab. Acquisition tab, you can start your experiment very easily by clicking Smart Setup. For the Smart Setup, you need to know which dye you are using by adding the dye to the workflow by clicking Add Dye and Contrast methods. You can search for your dye over here. For example, the recently used dye will appear on the top of the panel over here. Once you're done, click OK. All the light path, the filters, will automatically adjust it to your input dyes, and you can start imaging right away. If you already created your experiment previously, you can use the selected experiment over here. At the Acquisition tab, you can start your experiment very easily by clicking the Smart Setup. The Smart Setup required the dye names in order to adjust and choose the right filter according to your sample. In order to do that, click Add Dyes and Contrast method over here. You can search for your sample dyes from the dye database over here. The recently selected dye will appear on the top of the screen. Once you're done, click OK. From the blank experiment, you can now see the dye names will appear on the screen, and each of it will be adjusted according to your dye names. Another easy way to start your experiment is to select the previously recorded experiment from the list. To that, to start your experiment, click Live. By clicking Live, your sample will appear on the screen. Adjust your sample position according to your desire. To adjust the brightness of your sample, you can adjust it either via the brightness of the LED light source or the exposure time of the digital camera. In order to determine which it is already good enough, you can select Range Indicator and translate the signal into black and white. The red pixel over here indicates that it is oversaturated. You can either lower it down by decreasing the exposure time over here. Then you can now move on to the next dye you are using. For example, side 3 here, the signal is quite weak. I can increase more exposure time just to make it brighter. Once you're done with your sample, click Stop. From the list, you can see that there are many dyes to be selected. If you are not going to use it, just uncheck it. By clicking Snap, the software will automatically adjust your sample and start recording the fluorescent channel according to your selected dyes. By clicking Split, it will split two channels out from each other. Those two are the individual channels, and this one is the merge channel image of your sample. Once you're done with your sample, you can go to Graphics by clicking this ruler here to apply the scale bar to your sample. If the format is not what you really like, by clicking the right-click Format Graphical Elements, you can now change the format of your scale bar. For example, to make the line thicker, to make the text bigger. If you want to use this format for further use, click Set as New Global Default over here, and then click Close. The scale bar can be later on deleted. And once you reapply the scale bar again, the format will be according to the format you recently adjusted. Add the arrow, the text, the square, circle, or the irregular freehand drawing to your image. Each of the annotation will give you the area and the mean fluorescent intensity of each channel. In order to get those measurements, you can go to Measure. You don't have to write it down. You can select it all and then Control-C and paste it to your notes or Microsoft Excel for further use. Those graphics can be further removed once it is not needed anymore. I strongly recommend it for you to save your image under the ZEISS format. The ZEISS stands for Count Size Image. It will contain all the desired information of your sample. For example, by clicking Info, it will tell you when you are recording your image, which microscope you're using, the objective lens you're using, including your scaling. To do that, click File and click Save As. And then you can change your name over here and then click Save. In order to repeat your experiment by using the same setting as you are doing now, you can click Reuse. It will say that if you would like to repeat your experiment by using the previously used parameters, you can just open your previous image and then click Reuse just to get the parameter out of that image. And now you can start imaging right away. In order to get your previously used parameters to repeat your experiment, open your image and then click Reuse. in order to repeat your experiment, you can open your image and then click reuse to gain your previously used parameters. And then you can start imaging right away. If you would like to repeat your experiment by using the previously used parameters, you can just open your previous image and then click reuse just to get the parameter out of that image. And now you can start imaging right away. To acquire the XYZ image or the Z-stack image, activate the Z-stack here. You can see the small icon just pop up from the 2D images to the 3D images. Once you activate Z-stack, the multidimensional acquisition window will pop up. There are two ways to start working with the Z-stack. The first one is the first and last. Set first, set last will set the first stack and the last stack that will cover the whole range of the thickness of your samples. By clicking center, it will start from the center and it will fix either interval or the number of slices of your sample according to your preference. Then it will just expand the number up and down according to your input number. I will show you how to work with the set first and last first. By doing this, you're clicking live. Once you're clicking live, you scroll your mouse or move your focus further away from the focus and reach your desired distance. You can click set first. Then scroll down to find your focus and then further away to the other side. Then set last. You click optimal to determine the optimal thickness of your slices depending on your objective lens you are using. Once you are done, click stop and then click start experiment. There are two ways to work with your samples on the Z-stack. The sample is showing here is all channel per slide, which means for each Z-stack, it will image each channel first and then move on to the next Z position. Another way is full Z-stack per track. The full Z-stack per track, just like over here, it will start acquiring your image from the first channel first. By acquiring the first channel for all of the Z-stack, once done, it will go back to the first position and then start with the next channel again until it completes the whole Z-stack. This is your result. Once your Z-stack image is done, you can preview your image. Under dimension tabs over here, you can see that it will show the Z position over here, and you can scroll up and down and explore your image through each of the stacks. Further display of your sample can be done via orthogonal view. The orthogonal view will show you the dimension and the cut lines of your samples. The big image in the middle is the XY plane. The upper panel is the XZ plane, while on the right is the YZ plane. You can move your crosshair to see where your sample is in these 3D images. For sample which some of the organelles or some parts cannot be seen from some of the Z-stack, you can combine them together by applying the maximum intensity projection or the MIP to your image, and it will combine all of the signals from your sample into one 2D image. You can extract this MIP image over here by clicking New Image from the XY plane and click Create. By clicking this, now you can get your MIP or the maximum intensity projection image from your Z-stack image. The blue border lines which represent the Z-stack can be removed further in. Now, you would like to export your image to the normal image format to further work with other programs you are using. You go to Processing tab and search for the command of the image export. You click Image Export and then input your image over here by either click the drop down and select the desired image or drag the name from the tab from the top to the input panel. Now scroll up a bit to the parameters. Now you can choose the desired file type from the drop down. It can be JPEG, BMP, TIFF, PNG. I will show you how to work with TIFF file with no compression. Now, the default display, the default parameter here will allow you to burn in the annotation. From the current situation, the annotation that we have here is a scale bar over here. Now it already chose the merge channel image to be exported, which is this image. If you would like to have the individual channel images to be extracted along with the merge image, you need to check this one as well. If you want either one of these, you can just uncheck the others. Right now, we are working with the Z-stack image. You can extract some of the images to be extracted and exported as well. By clicking Define Subset, it will show you which parameter can be extracted. Under Channels, we have two channels here, for example. If you would like to extract or export only the FitZ images, so now you can turn off the ciphering. Under the Z position as well, you can extract or export which parameter you are using. For example, I would like to extract just only one single image. I would just type in the position that I would love to be exported. Now you can just go export to your desired destination. And you can now change your prefix or the file name from here. And then go on to the top and click Apply. From now, the only one image that I've got will be just one single channel of FitZ from the Z-stack number 6. For bright field or the transmitted light images, choose the BF experiment from the list. Don't forget to push the knob to the end to activate the axial cam 305 color to image your sample. Clicking Light. work with the transmitted light or the bright field image, choose the BF experiment from the list. By clicking Live, you start previewing the sample. Right now, you can adjust the brightness of your sample by adjusting the exposure time over here. By adding more time, you make your sample brighter. Once you're done, you click Stop and click Snap. To work with if you have to have a bigger field of view of your image by doing a simple tie, next to the Snap button, click the drop down and you can see that there are the preset tile snap of the image. For example, 3x3 snap will include 9 images of your field of view together. Now it will start acquiring the 9 images right away. The image that you see here is not complete yet because each of the field of view is not completely tiled together. You can see some of the border over here. To fix that, you go to Processing, search for the method called Stitching. Input your image over here and then choose Fuse Tile to fuse those tiles together and then click Apply. Wait for the blue line to finish. Now your image is perfectly stitched and seamless. For the more complex commands of the tiling, you click Tiles under the ZEISS tag. And then it will show the multidimensional acquisition windows of tiles again. You click Show Viewer to start inputting your command. For tiles, click the first button over here and now you can choose or input the number to make your tiles region. It can be any number. For example, it can be 5 by 2. And you click Add Tile Region. You click Live again. To make sure that your sample is in focus, by adjusting any focus, you need to update your Z position. Going to the tile region you input earlier and then right-click and choose Set Current Set for the selected tile regions. Once you're done, you click Stop and click Start Experiment to start acquiring your tile images. Now your image is done. Don't forget to go to Processing tab and do the stitching before you save your image. For the use of oil objective lens, you need to apply the oil to your sample first. Put a small drop on the sample like this and turn to the touchscreen and click the 100x oil objective lens. Now you're ready to use your oil objective lens. After applying the oil and use the oil objective lens, you can now start working with your experiment. Clicking live, you can now see your preview image. Once you're ready, click snap. The image, you can further process it and enhance some of the brightness of your sample by clicking each of the channel. You can either cut out the background of your image by scrolling this panel to the right, or make it brighter by move it to the left-hand side. You can do it with other channel as well. This is your final image. Once you're done working with your oil objective lens, I strongly recommend you to clean the oil objective lens after every use. In order to do this, move to position 7 for easier cleaning. Now you can lower your stage and remove your slide. Now, use the lens cleaning paper to wipe out the oil from the front lens, like this. If it's just clean enough, I recommend you to use the absolute ethanol to clean the lens. Once you finish working with ZEN, you can now just turn off your ZEN software by clicking Exit on the right-hand side of the software. Now, you did something without saving. It will ask you, would you like to save your documents? If you do not wish to save anything, you can just click Unselect All and then click OK. The ZEN software is now turned off. The ZEN service window will pop up just to shut down the communication between ZEN software and the microscope. Wait until this window disappears. Then you can just turn off your PC. To shut down the system, just turn off the components in the reverse order. PC is number 5. Now you can just turn off your PC. Then turn off the microscope, which is number 4. Turn off the supply, number 3. Turn off the SMC 2009, which is number 2. And turn off the UPS, which is number 1.